Dear students, welcome to the video lecture of operation on pointers. So operation on pointers. See pointer arithmetic operations we are going to discuss. Consider the below table. We have declared some of the variable and also assume some address for the declared variable. So the data type is an integer. The initial address is 4000. By performing an increment, unit increment operator, it will go to 4002. Okay, our control go to the memory location address 4002. 4000 because okay, the bytes required for integer is 2. For a same integer operation, the initial address is 4000. When you perform a unary decrement operator, the certain value is 3992. Okay, so it will decrement means 2 bytes. Character variable increment and decrement 1 byte. So for initial address is 4000, perform a increment on character point variable, resultant value will increase by 1. So here initial address is 4000, the resultant value is 4001. Likewise, for a character decrement, okay, the initial value is reduced by 1 byte, that is 3999. A float consume 4 byte. For increment decrementing operator, unary operator with the float variable will increase 4 bytes or decrease 4 bytes. So 4000 is initial address. By incrementing operation, the address of the operation is 4004. So initial address is 4000. By decrementing it, we will have a value of 3996. Okay. For a long, increment will lead to 4 bytes, so increase of 4 bytes, and as well as decrease decrement operator decrease the 4 bytes. So for long initial address is 4000. By incrementing, it will increase to 4004. For 4000 for as the initial address, decrement operator, unary decrement operator, okay, will lead to the address 3996. Okay, because the 4 bytes which required by the long will added when we using increment operator and decremented when using a post decrement operator. Incrementing pointer. Incrementing a pointer is generally used in the array because we have a continuous memory in the array. We know the content of the next memory location because the array will allocate the values in continuous memory location. You want to travel in the various memory location from the base address, you have to use the increment operator. Incrementing a pointer variable depend upon the data type of the pointer variable. So incrementing a pointer variable depends upon the data type of the pointer variable. The value, resultant value will be depend upon the data type of the variable. For example, here we'll see an example program. Here stdio.h and header file is included. It's a void main. I'm declaring a variable integer star pytr is a pointer variable. We are able to explicitly allocate the memory address. You have to give a data type star, the open and close parenthesis followed by 1000. Now what will happen? We are allocating address, okay, explicitly to this as a 1000 in the pointer variable. So this is a very important point. Okay, we should understand. And in declaration, the pointer variable equal to initialization and data type of the pointer variable integer star. Okay, for float pointer variable float star you have to give, and you will have to give the memory address that the value will be stored as a memory address in the pointer variable. So I'm incrementing the pointer variable by 1, pytr equal to pytr plus 1. Okay, what will happen? Okay, it is integer data type. So what will happen? So the concerned bytes will be added. Okay, new value of the pointer variable percentage u pytr. The pytr value will be displayed here. Okay, the new value after increment operator, the new value will be displayed here. Okay, we'll see it in the example. You'll see it in this example. Go to actually value f equal to. After I'm going to activate the zoom tool. This is zoom tool used to zoom in the program which discussed. Okay, the slide okay is given here. We'll execute and find the result. Execute the program. Okay, so what is the value? The new value is 1004. Okay, just a minute. Let me check. The initial value of PTR is 1000. After incrementing by 1, because integer will take 4 bytes, the 4 is added. The new value is printed as 1004. So we'll discuss the next example, decrementing a pointer variable. Decrementing a pointer variable, decrementing a pointer to an integer data will cause a value decremented by 2. Okay, here we are having a, okay, this it will consume 4 bytes, so it will decremented by 4. Okay, some compiler will allocate 2 bytes, other compiler Okay, it will decrement it by 2. Code blocks allocating 4, compiler allocate 4 bytes, so it will decrement it by 4 bytes. This differ from compiler to compiler as memory required to store the integer value vary from compiler to compiler. If you have the turbo C, it will take 2 bytes, but here the compiler of the code blocks, it will take our environment take the 4 bytes. So the same program, as std.h and integer main and declaring a main integer star ptr as a point variable. I'm allocating address explicitly. Integer star and 1000 is allocated. Okay, point variable will contain the address 1000. So PTR equal to PTR minus 1, I'm minusing pointer variable. So what will happen? We'll minus the 4 bytes. So the resultant value will be new value of pointer equal to PTR equal to percentage U. Okay, percentage U stands for, okay, the unsigned integer. So PTR, now it will return the value 9996. Okay, actually 996 is our value. So execute the program and check the result. This is a program we discussed now. Okay, same program. Allocating integer address to 1000. I'm performing a unary. I'm minusing one value from the pointer variable, and as well as what I'm doing, I'm printing a value, new value of PTR equal to percentage U comma PTR. You will run and check the result. Yes, 9096. So initial value is 1000. The minus will decrement the bytes for because the integer will take 4 bytes. So 9996 is the resultant value. Then actually for next subtracting a 2-pointer variable, it means that subtracting a 2 pointers. Differentiating means subtracting 2 pointers. Subtracting give a total number of objects between them. Okay, total number of objects between them. Subtraction indicate how apart the 2 pointers are, how one pointer is distant from other pointer. For example, okay, I'm declaring integer variable and declaring 2 integer pointer variables star ptr1 star ptr2. Okay, separated by comma and give a semicolon. So ptr1 equal to address of num. Okay, address of num is stored in the pointer variable ptr1. Okay, what I'm doing, and ptr2 equal to ptr1 plus 2. Okay, I'm incrementing by 2. What will happen? Okay, by initial value, by incrementing by 2, it is a what point? It is an integer pointer. So 8 bytes will get increased. Okay, for the ptr2. Now I am performing a ptr2 minus ptr1. We will get the difference. Okay, so it's an integer main. That's why they will give a value return 0. We'll run the program and check the result now. Okay, this is a subtraction between the 2 pointer. The program we discussed now is, okay, given here. The program we discussed here is, okay, it's a given. We'll run the program and check the result. The program check this. It will give a value 2. Okay, we'll check. Okay, we'll display the value. We'll just will fine tune the program. Printf ptr1 equal to percentage U. I'm giving the value of ptr1. Okay, then actually then printf printf ptr2. Okay, equal to percentage U. I am printing a value ptr2. Okay, so here ptr1 ptr1 equal to percentage U. I'm giving a value ptr1. Okay, then I'm give the value. I'm just printing the value percentage U. So ptr1 minus ptr2 equal to percentage U. Check, see, and we execute the program, check the result. Okay. The printf. To give a slash n to display value in the new line. Run the program. Okay, so ptr1 value is 24. Okay, ptr2 value is 32. Okay, 24 plus 4 equal to, okay, what will happen? Okay, 28 and 32 difference is, okay, 2 spaces. Okay, 2 spaces is a difference. So 2 objects are between them. Okay, 28 on object will store, and 32 is the next object value. So it will have 2 spaces that is displayed here. That's where separate indicate apart that to how apart 2 pointers are. So 2 pointers apart 2 spaces. Okay, that is displayed here. Okay, that is displayed here. Okay, the PTR2 is 2 spaces because 28 and 32, so 2 spaces apart from PTR1. So, okay, that is displayed here. Okay, that's it for this. First, we have to discuss one more thing. That is some invalid operator. Some operators are not possible in the pointer variable. So next we are going to discuss about the comparison between the two pointers. Comparison between the two pointers. Pointer comparison is valid only two pointers are pointing the same array. Then only we are able to perform pointer comparison. Or relational operations can be used for comparing a pointer of the same type. Okay, pointer of the same data type can be compared. All equality inequality operator can be used with the all pointer types. All equality inequality operator are used with the pointers type for comparison. Pointers cannot be divided or multiplied. You cannot divide and multiply the pointer. So a program is given here. Okay, then we will see the example. We'll discuss the example. Uh, Program name comparison. So integer PTR1 equal to 1000, PTR2 equal to 2000. It will print PTR1 greater than PTR2 greater than PTR1. It will print PTR2 is far from PTR2. Okay, this is comparison is performed. Okay, I mean allocate address 1000 for a PTR1, allocate address 2000 for a PTR2. The PTR1 greater than PTR2, it will print PTR1 is far from PTR2. Okay, this is a program given here. PTR1 is 1000. Okay, so I'm allocating address. That's why integer star 1000 is given. PTR2 is a pointer variable. Integer star 2000 is given. PTR2 address is 2000. PTR2 is greater than PTR1. Will print PTR2 is far from PTR2. Okay, we'll run and check the program. Yes, see the result. See the result. PTR is 2000. That's why it will print PTR2 is far from PTR2 is far from PTR1. Okay, that is the output. And next we have to discuss about the invalid operation. Some operations are invalid for a pointer. Some C pointer invalid operation. Some operations are invalid. No one can perform arithmetic operation on pointer such as increment. No, one can perform arithmetic operator arithmetic. One can perform different arithmetic operation on pointers such as increment and decrement, but still we have some more arithmetic operation that cannot be performed on pointer. Adding to address, multiplying to address, division of to address, modulo operation, and as well as cannot perform a bitwise and or XOR operation on pointers. We are not able to perform a NOT operation or negation operation on pointers. So these operations are not allowed on the pointer. Only subtraction is allowed between the comparison is allowed. Addition, multiplication, division. So arithmetic operator, modulo operation. So for arithmetic operator and or XOR bitwise operator, we cannot perform a NOT negation. Also the bitwise operator cannot perform with the pointer variable. So that's it for the video lecture. Thanks for watching it. Thank you.